Okay, so this set of video notes is on solving quadratics. In the previous lesson, we learned how to factor, or not really learned, but sort of relearned, because factoring is an Algebra 1 concept. We learned how to factor the factoring quadratics several ways. There was by grouping, and you see here factoring by difference of squares. When you have two sets of perfect squares, you can you can factor it using the method through difference of squares. But today we're going to focus on the solving aspect of it. So, once you factored it, or whatever way that you factored it, how do we actually solve now these? Now, the difference between solving and factoring is really one key thing, and that is the presence of an equal sign. If you'll notice in the factoring problems above, you can scroll up or whatever above, but you'll see that there is no equal sign, which tells you that you need to factor. Once there becomes an equal sign present, you then know that you need to solve these. So there are, again, various ways that you can do this. One is, factoring first, factoring by grouping. Sometimes it's just a GCF. So sometimes you see that there's a common factor throughout all of them, and you can factor that as well. So one of the ways that we mentioned, and one of the more common ways, is by factoring. And this is the old method of doing sort of your ABC. We call it the ABC method, where you take your A times your C. 3 times 12 is 36. And then you bring down your B. So you ask yourself, well, what multiplies to be 36? And also adds, and actually this is negative 36. 3 times negative 12 is negative 36. What multiplies to be negative 36 and adds to be 5? And it might take you a few minutes to figure this one out, but I'll go ahead and do it. It is 9 and negative 4. 9 and negative 4 multiplied is negative 36. And 9 and negative 4 added together is 5. So what you do is you go to your dead cartoon eyes, which is x, bring down your factors, plus 9, and x minus 4, just like we did before. Nothing's changed here. Now, the one thing we have to recognize is the fact that our a is not 1. Okay, remember, when your a is not 1, you need to take these factors and divide by that a. Now, if it divides into it evenly, like this one does, 9 divided by 3 does divide evenly, you just divide it, so it's x plus 3. But when it does not divide evenly, like the term here on the right, this does not divide evenly, then you bring the denominator out in front of the x. So what this becomes now is 3x minus 4. So now it's completely factored, and this is what we did in the steps before. We would, in the problems before, we would factor, and then that was it. The difference here is we have an equal sign, so I do have to actually solve these. And how you solve them is you just take each one of these here and set them equal to 0. Now I'll put them over here so we have a little bit more room, but basically I set x plus 3 equal to 0, and 3x minus 4 equal to 0. Now, you just solve for x. So if I move the 3 to the other side, it becomes negative, so I get x equals negative 3, and there's one of my solutions. Here I bring the negative 4 over, so it becomes positive 4. So that's an equal sign. 3x equals positive 4. Divide by 3. Divide by 3, and you get x equals 4/3 since it does not divide. So that's solving. The only difference here is we're just adding this extra step where you do need to set them equal to 0 once they've been factored. So I'm going to go ahead and pause here. You can use that as an example to try the problem below it. So go ahead and try to pause the video and see if you can do this one by yourself using a similar method here now, but notice your a is not 1, so you don't need to worry about dividing your factors, but follow the same steps and see if you can get the problem below, and then play the video to show the answer. Okay, so here I have taken the ABC method again, and a times c is negative 28, b is negative 3. The numbers that multiply to be negative 28 and add to be negative 3 are negative 7 and 4. So I do my dead cartoon eyes, drop down my factors into those. And now, since my a is 1, I don't need to worry about dividing these factors. So I can go right to the step which involves me setting them equal to 0. So x minus 7 equals 0 and x plus 4 equals 0. Bringing the negative 7 over, it changes signs to a positive 7. Bringing the positive 4 to the other side, it becomes negative 4. And so there are my solutions. Pretty simple. Now, it does require you to know sort of what you're doing in the factoring part. The solving part is probably the easier part. But looking at a problem like this and understanding, okay, what do I do here? A, B, C, whatever, but you have to be able to look at this problem right here and notice that first of all, it's not a quadratic. You have x to the third. That should tell you right off the bat I have too many x's. It should be x squared, but when you see x to the third, this is no longer a quadratic. And so what you should see is that you have an x in every single term. There is an x in every single term. So we are going to have to take an x out first. So x will come out. All you do is rewrite everything with one less x. And it ends up like that, equals 0. So we're not going to worry about this x till a little bit later, but we are going to factor this here inside the parentheses. Using our method, our ABC method like we've done before, we can simply do a times c. 15 times negative 2 is negative 30. B right here is negative 1. So I have to find two numbers that when multiplied will be negative 30 and add to be negative 1. Again, if you get stuck here, just write out all the numbers that multiply to be 30. You can do 1 times 30. 1 times 30. 2 times 15. One of these combinations is going to have to add to be negative 1. Clearly those two don't. But if we keep going down, you'll see that they start getting smaller and smaller and smaller. 5 times 6, and then all of a sudden you're like, whoa, okay, wait a minute. I can probably get those numbers to add to be negative 1 if I just simply make the 6 negative. So 5 and negative 6 would be negative 1, and that just happens to be the answer. Because 5 times negative 6 is negative 30, and 5 plus a negative 6 is negative 1. Do our dead cartoon eyes, which is the parentheses with the x's in them. Drop down our factors, which are positive 5 and negative 6. We do have to remember that our a right here is not 1. Okay, so we will have to divide those by 15. Now in this case, I will have to reduce these fractions before I do anything else. So 5 over 15 reduces to 1/3. Okay, so this is 1/3, and this is going to be, let's see, 2/5. 2/5. Either way, they don't divide, so the denominator will have to go in front in both of these. So what I end up with here is 3x plus 1. Okay, because this isn't here anymore. And then over here I have 5x minus 2. And that's the factoring part. Now the next part here is to now set them equal to 0. So I have 3x plus 1 equals 0, and I have 5x minus 2 equals 0. By bringing the 1 over, it becomes negative 1, so it's 3x minus 1, or equals negative 1. Divide by 3, divide by 3, and I get x equals negative 1/3. Here, bringing the negative 2 across makes it positive, so I get 5x equals positive 2, divide by 5, divide by 5, you get x equals 2/5. And that ends up being your answer there. And that's solving. Okay, at least factoring and solving. So I want you to go ahead and pause the video and attempt to do the one below on your own. Notice again, you're going to have to take a GCF out. This time it's not a letter though. I mean, we do have x squared, so we're good. I don't have an x in all of them. But you will notice that a number can be taken out of all of these. Which brings me to something I forgot in the previous problem. I forgot something. I apologize. Remember that x we took out in the very, very beginning? Yeah, it's when we get down here, you had to have x down there too. So I actually had to set this equal to 0, this equal to 0, and this equal to 0. So I should have gotten 3 answers, with my final answer being the x equal to 0, which is from this one right here. Okay. Can't forget about that x that's out there. Okay, pause the video, try the problem below, and play when you're ready for the answer. Okay, here you have, I factored out a 3. So I divide everything by 3, I get x squared plus 8x plus 16. So what that leaves me with is a times c is 16, b is 8. What multiplies to be 16 adds to be 8 is 4 and 4. So when I draw my dead cartoon eyes, I have plus 4 and plus 4 in there, and I drop down the 3. Now the difference between this problem and the previous problem is there is no variable. There is no variable out here, so I don't have to set this equal to 0. Okay, the previous problem had a variable out here, so therefore I would have to set it equal to 0, but there is no variable out here, so I do not have to set this equal to 0. Only the ones that contain variables. So I can set x plus 4 equal to 0, x plus 4 equals to 0. Now I'm going to get the same answer for both of these because they are the same, but when I bring the 4 over, I get x equals negative 4. And I don't have to write it again because I'll get the same answer. So this time I only have one answer. Okay. Next page. The last piece here is then to actually solve by graphing. So this one is a little bit different because this involves a little bit more things, but basically solving by graphing is actually using the information that you learned in the previous problem, like getting your solving for x, and then using what's new, what's not new, you learned it in Algebra 1, the vertex formula, to find the vertex of the problem and graph it that way. So let's get started. When graphing problems, they start out the same. Ignore the graph for a second and just solve the problem like you did in the previous problems. So if we're looking at a problem like this, we just solve it. So we're going to go ahead and factor. Some of you guys might be pretty good at this and be able to figure out what multiplies to be negative 5 and adds to be negative 4. Okay, so I mean, negative 5, we can write this out if you want to, negative 4, what multiplies to be negative 5 and adds to be negative 4. Hopefully, by now we've done a pretty good job of figuring this, this stuff out in our heads, but it multiplies to be negative 5, adds to be negative 4, it's going to be negative 5 and 1. So when we do that in our dead cartoon eyes, that's x minus 5 and x plus 1. And when we solve this, we get x equals 5 and x equals negative 1. And those end up being, and what you should have remembered in Algebra 1 is those are actually your solutions or x-intercepts. So if I know that it's going to cross at 5 and negative 1, those are my x-intercepts, I can go over here to my graph and plot dots at x equals 5 and x equals negative 1. Okay, you only need 3 points in order to graph. A parabola, you only need 3. So we just need to find one more, and that one more ends up being our vertex. The vertex is found using the formula up here. Okay, x is opposite of b over 2a. Okay, the vertex is going to be a coordinate point. So the vertex will be a coordinate point involving x and y. Well, when you do vertex, it's x equals the opposite of b over 2a. And you plot the same stuff as you were doing before. It's the same b and a we're doing before. So when we do this, x equals opposite of b. Well, our b it's right up here. Here's our b right there. -4. So opposite of that is +4 over 2 times my a. My a is 1, so 2 times 1. You end up with 4 over 2, and 4 divided by 2 is 2. Now that is only the x value. Okay, this is only the x value of my coordinates. So if you think about it, all I have is 2 comma something. I need the y value in order to plot a coordinate point. So what we need to do now is take our 2 that we have already for x and just plug it into the equation. So if I plug it into the equation above for x, it becomes 2 squared minus 4 times 2 minus 5 equals 0. When you do that, you get 4. That's -8, -5. I get -9. And that will serve as my y. That'll serve to go in right here in that spot. So now I have a coordinate for another point, which happens to be my vertex, at 2, -9. So if I slide over to my graph, I can plot a point at 2, -9, which is down here. And now I can complete my parabola. A couple other points that you can also do if you wanted to. What we'll learn too is this right here, the -5. Whatever your c is always the y-intercept. Your c is always the y-intercept, the number that's by itself. So that -5 is my y-intercept. So I actually have another point here I can plot if I want to, and then this serves as sort of, remember, the parabolas are symmetrical, so we can plot an identical point on the other side. And now we have an even more accurate parabola that we can draw. And that's graphing. So use that as an example to try and plot the problem below. Pause the video, try the problem below, and see if you can do this on your own. Okay, so there's the answer to this particular problem. At first, I factored here. I factored it into x plus 4 and x plus 2, which when I solved was x equals -4 and x equals -2. Those ended up being my x-intercepts at -4 and -2. I then used the vertex formula, which is x equals the opposite of b over 2 times a, and I got -3. That it becomes the x-coordinate of my vertex. So when I plug it back into the equation, I solve for the answer, and that gives me the y value. So my vertex is at -3, -1, and that serves that point there. A couple other points I placed is the y-intercept. Since my c is my y-intercept at 8, I can plot a point there at 8. Since parabolas are symmetrical, I have a matching point on this side of the parabola from the y-intercept, which gives me 5 points, which basically just gives me a more accurate parabola. Now, one thing that also you can do with these graphing type of problems is just plug it in your graphing calculator. You can check your answer. Okay, take this, go to the y equals in your calculator, and just plug this in. Don't put the equals 0. Just put y equals x squared plus 6x plus 8 in your calculator and hit graph. It should look like this. And actually, you can, and I'll show you when we do this together, that you can actually find all of these pieces using the graphing calculator as well. So a good way to check your answer. Well, that's solving. We did solving through factoring, and then here solving by graphing. So that's it. Please try the problems and big ideas, earn that G-Buck, and also self-assess. Get some practice in. You'll have a quiz over this next class. Thanks.